Welcome to my DE4 Sensing IoT project entitled MoodSense. MoodSense is a mobile application that is able to predict the mood and attitude of individuals within a local area, allowing the users to avoid or prepare for negative interactions during commutes and travels. To accomplish this, light luminous data is collected using a digital light sensor. This particular sensor was chosen as it is able to approximate a human eye response level to light. In addition, sentiment data was also collected from tweets using an API in order to determine the relationship between light levels and people's moods. Data was collected over a span of 2 weeks, and the light sensor remained fixed in position the entire time. It was placed on a south-facing window in order to maximize its exposure to sunlight and collect realistic results. Once the data has been collected and analyzed, a mobile app was developed using React Native. In order to run the app, the relevant node file must be accessed and started in the terminal and hosted locally. This will develop a QR code that can be accessed using Expo, an open source React Native platform. Once the QR code has been scanned, the user can have access to the app. They must first wait for it to load, and then they are shown the first initial prediction of the mood in their local area. If at any point the user feels like the information being shown is out of date, they're able to drag down the screen and refresh the page. This will update the data and animate the information back on the screen. The bars are either orange, red, or green, depicting the level of the mood in the local area. The users can also swipe to the left and get access to the mood predictions for that day. This would visualize the moods for the next 20-minute period in 5-minute intervals. If the user wants to see the information on the raw data that was collected for that day, they can toggle the data button at the bottom of the screen and they'll be shown two plots. The first plot, sentiment distribution plot, shows the distribution of different moods that were experienced in the local area, whilst the historic data plot shows the raw data as it varies across time for the local area for the entire day. This data can also be refreshed to ensure that the most up-to-date information is being shown to the user. This data is sent to the app from a back-end web server developed in Node-RED. This web server handles all of the computational complexity of the app, such as calculating the new prediction for mood, and also retrieving the current and previous mood readings that were collected from the light sensor and tweet API. This web server is programmed in JavaScript and is returned to the app in a JSON format. And that concludes this brief overview of MoodSense, an app designed to improve interactions with individuals along commutes and travels. Thank you for watching.